Hello, everybody. It is Mr. Odom, and today I'm going to cover section 9.5. I was going to say 5.5. 9.5, which is the volumes of pyramids. So we start with a quote from a famous football coach, and it is: "The quality of a person's life is in direct proportion to their commitment to excellence, regardless of their chosen field of endeavor." So direct proportion means that if one side increases, so does the other. If one side decreases, so does the other. So that's direct proportion. So I'm going to pause for a moment of reflection. And as always, you can write in your composition book, write your thoughts in your composition book, or um, in a journal, or wherever you want. If you want to share with me, you can, but you do not have to. That's up to you. So the video pause now. Okay, so we're back, and we are going to learn how to find the volumes of pyramids. So we've talked about how to find the volumes of prisms, and that formula, volume equals area of the base times the height. Well, you're going to see that this formula we're going to look at for the volume of pyramids is almost exactly the same. All right, so you got to make sure you bring all this stuff, all your tools, so that you can learn and retain the information. So, how do we find the volume of a pyramid? There's a formula and a process for finding that volume, and that's what we're going to look at. So, here is the formula right here. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Okay, so here is the height of the pyramid, and then you have to find the area of the base, which could be a square, a rectangle, a triangle, an octagon. It could be many different shapes. All right, but you have to find that area, and you multiply it by the height, and then you multiply that by 1/3. Another way, this is the way I write the formula because it's easier for my brain to handle it. I say it's the area of the base. Volume of a pyramid is the area of the base times the height divided by 3. Okay, so this is the formula that you will see me use as we work through examples. The textbook, they will use this formula. So you'll get to see how both of them work. Let's look at some examples. So we got to find the volume of this pyramid. And so this pyramid, oh, actually, let me go back and let me pause. I forgot to pause. I'm so excited to work out some problems. I forgot to pause. So I'm going to pause the video for a moment so that you can write these formulas in your composition book. Okay, now I can go ahead and move forward. There we go. Let's look at an example. Let's find the volume of this pyramid. Notice that capital B is given to us. It's 48 millimeters squared. So you do not have to find the area of this. How many sides are on this figure? 1, 2, 3, 4, 5, 6-sided base, which is a hexagon. So you don't have to find that area. They give it to you. So that makes this pretty easy. So what do? We write down the formula. And we just plug in the numbers that we have. We do the multiplication, and then the volume is 144 cubic millimeters. Volume equals 144 millimeters cubed. So that's how I would write it. Now, using the formula the way that I like to do it, we'll just work that out so you can see that too. So we have the area of the base, which is 48, times the height of the pyramid, which is 9, divided by 3. So the reason I like this is because I can see the canceling. All right, I can see that there's some canceling that goes on. I can cancel with the 3 and the 48 or the 3 and the 9. So I'll just pick the 3 and the 9. I know 9 divided by 3 is 3. And then I can go ahead and figure out what is 48 times 3. And it turns out it is 144. And then I put my units, millimeters, cubed. Volume is always cubed. So there you can see how the textbook uses 1/3 times the area of the base times the height, and then how I use the formula this way. Both are correct. All right, let's find the volume of these two pyramids. All right, so we write down the formula. We need to find the area of that base, which is 3 times 4, 4 times 3, because it's a rectangle. All right, so there you go. And I do the math, I get 28. So the volume is 28 cubic feet. What about for B? This is a triangular pyramid. A is a rectangular pyramid because the base is a rectangle. So B is a triangular pyramid. And so we use the formula again. All right. So in red, what are we doing here? This part right here, the 1/3 or 1/2 times the 17.5 times 6, that is the formula for the area of a triangle. We take the base times the height divided by 2. Another way to write that formula is 1/2 times the base times the height. So you see that that's what is in red. And then we multiply that by the height of the pyramid, and we just do the work. That's it. We get 175. So the volume of that pyramid is 175 cubic meters. All right, time for you guys to practice. So the video is going to pause now so that you can work this problem out. All right, what did you guys get? Here's how I solved it. I wrote down the formula and I just plugged in the numbers. The area of the base is 21 feet squared or square feet, and the height of the pyramid is 6. You see the canceling that I did with the 3 and the 21, and so I end up with just having to multiply 7 and 6 together, and I get 42 cubic feet. All right, so the video is going to pause now so that you can work out this problem. All right, so we're back. And again, write down the formula. The area of the base, I calculated off to the side. That's just my own little habit to figure out what capital B is. So you can see I figured out what the area of the base is. And then I just multiply that by the height of the pyramid. And I end up with 560 over 3. And 3 goes into 560, 186 times, and there's a remainder of 2. So the volume equals 186 and 2/3 inches cubed. Another way you could have written that, if you used your calculator, probably ended up with this 186.6 repeating inches cubed. Okay, so there's our volume. Let's look at one more. This is a triangular pyramid. All right. So the video is going to pause so that you can work this problem out. All right. So we're back. And let's see what we do. Here's all my work. First, I found capital B. Okay. I found capital B. And how did I do that? Well, I have this triangle and I labeled the base and the height of it right here. And I found that area, and it was 63 square centimeters. And then I just plug that into the formula for volume, and I get my answer, which is 231 cubic centimeters. All right, let's look at this problem. The volume of sunscreen in bottle B is about how many times the volume in bottle A? So we're going to assume that even though they're not quite pyramids, they look like pyramids. We're going to assume that those are pyramids. All right. So for A, let's use the formula for volume of a pyramid. And let's estimate the amount of sunscreen in each bottle. Okay. So I figure out for bottle A, there's about 4 cubic inches of sunscreen in that bottle. And then bottle B, there's about 6 cubic inches of sunscreen in that bottle. All right. So about how many times larger is bottle B than I'm sorry, How many times larger is the volume of the sunscreen in bottle B versus the amount of sunscreen in bottle A? All right. So notice what I did. I took the 6 and divided it by 4 because I wanted to know how many times bigger this bottle was than this one, or larger. And so the volume of sunscreen in bottle B is about 1.5 times the volume in bottle A. So let's figure out which one is the better buy. All right. So let's find the unit cost for each bottle. So for bottle A, it's $9.96 for 4 cubic inches. So we can see that for 1 cubic inch, it's $2.49 because we converted the rate into a unit rate. For bottle B, it's $14.40 for 6 cubic inches. And then what did we do? We converted that into a unit rate. And so you can see when they're both unit rates, you can see which one would be the better buy. It's actually, you get more for your money with bottle B, okay, because the unit cost is less than the unit cost of bottle A. All right, so there's a word problem for you. Hopefully that was helpful. And if you have some questions, the video is going to pause so you can ask me some questions about volume of pyramids. All right, so we're back. And so you know what happens at the end. I am Mr. Odom, and wow, it's gone already. Well, I am out.